So we're going to talk about trig function values as angles change and then also some special angles. So for this video, I highly recommend my free guided notes at divideandconquermath.com. Just there's a lot we're going through and I have like tables and pictures kind of already set up for you. So it just makes it easier to follow with this video. So let's assume that I have this situation here. So I have the same length hypotenuse in each picture. My question is, how is my angle A, how is it changing? Just based off of this with the hypotenuse always staying the same. Well, you can see that this angle size, it's increasing, right? We can see that it's getting bigger. And the real question is then, how does this impact the values of the trig functions? Okay, so let's start with sine. Sine is, so if I have sine of A, that's going to be opposite over hypotenuse. So think about this then. As this angle is increasing, so think about these ratios. This side is getting closer to like this side, right? In terms of like they're getting closer into being closer to the same number. We know the hypotenuse will always be the largest, but this is definitely getting closer to what the length of the hypotenuse is, right? So if sine is opposite over hypotenuse, then as A is increasing from 0 to 90 degrees, the value of sine of A is going to increase. Okay, so let's continue on with cosine. So what about cosine? So cosine of A, that's going to be my adjacent side over my hypotenuse. And so you can see as we go along here, as the angle increases, well, this side is getting smaller, right? And so this is going to be a small number then over a larger number. So the whole value of cosine will decrease. And then thinking about tangent, so with tangent, so tangent of A, that's going to be opposite over adjacent. So you can see here that like as we go along in this situation, the opposite side just continues to get bigger than this side as it gets smaller. So you could think of it that way. You could also remember tangent is sine over cosine. So sine is going to continue to get larger as our angle increases. Cosine will decrease. So you have a large number over a smaller number. So overall, the value of tangent is going to increase. Okay, so important just to know kind of what happens with these functions as we go along with the angles. And then I just want to remind you that our other trig functions, our three other trig functions, they're all reciprocals, right? So really they're going to then do the opposite thing. So if sine was increasing before, then cosecant of A as A increases is going to decrease. And if cosine was decreasing before, then secant of A is going to increase. So it's going to have kind of that opposite behavior. So I can describe this then as we continue to go from 0 degrees to 90 degrees. So as we increase, cosecant of A is going to decrease, secant of A is going to increase, and cotangent of A is going to decrease. And that really falls in line then with the behavior of the function and how reciprocals work. Okay, so where we can kind of play along with this or play with this a little bit is to determine if the following are true or false. So I've got two examples here. So we've got this case here. So tangent of 25 degrees, could this be less than tangent of 22 degrees? So this is where you have to think then about really like what we were just talking about here. So as we go from 0 to 90 degrees, so the bigger the angle gets, the tangent of that will also increase. So this is bigger, 25 degrees is bigger than 22 degrees. So this would actually be the bigger number, right? So for A, this would be false. Now, there are other ways I can kind of ask you this. I think a really tricky way I could ask you this type of question, cosine of 20 degrees is less than sine of 25 degrees. Now this is kind of tricky. I don't think you can really analyze this unless you get these more in a measure that you can really compare them. So what I'm referring to here is I think you need to use the co-function, which I talked about in my other video. So to find the co-function, I take sine of 25 degrees, that's going to be equal to, so cosine is a co-function with sine. So I take 90 degrees minus 25 degrees. So what this does is it allows me to write the equivalent of sine. The equivalent of sine is cosine. So the equivalent of sine of 25 degrees is cosine of 65 degrees. And so now I can see 25 degrees versus 65 degrees. Well, we know that as the angle increases, cosine decreases, right? So this would not be bigger. This would actually be smaller than this. So this would also be a false statement. So these are a little tricky and you got to think through them a little bit. Now, the other thing I want to talk about in this video are some special angles. So we're going to take a look at a few triangles that have some nice properties and they come up a lot. So let's start with the equilateral triangle. So what makes the equilateral triangle what it is? All sides are of equal length. And for our purposes, we're going to kind of continue on with this example. So just in the back of your mind, I want you to think of all the sides here are going to be 2. So just keep that in the back of your mind. It doesn't really matter right now, but we'll come back to that in a second. So a consequence of this then is that all angles have to be 60 degrees for an equilateral triangle. And like I said, we're pretending these lengths are 2. Okay, so we'll start there. And now what I want to do is I want to bisect this triangle. So boom. And so I'm going to cut this in half into these 2 triangles. So what ends up happening when I bisect then is this angle gets cut in half, right? So these are 30-degree angles, and then I've got 90-degree angles here, and this is still the 60. So I think of this as the 30, 60, 90 triangle or triangles as we have right now. Okay, so now what I want to do is I want to think about the lengths. So remember what we were talking about. We said that all sides of our equilateral triangle were 2. So if I bisected it, now this side down here, it was 2. Now it's 1 on each side for each triangle, right? So this makes sense. Okay, so the question is then, what is the other side? So we have this one side here. We don't know what the length of this is. So we got to figure this out. So we've got to use the good old Pythagorean theorem. So I go through 1 squared plus x squared equals 2 squared. And so I've got then, 1 plus x squared is 4. Subtract the 1, x squared is equal to 3. So I have x is equal to plus or minus the square root of 3. I always like to remind you that you've got the plus or minus here because sometimes, depending on the application, you actually do need the minus. But in this case, we are talking about just general lengths, so we just need everything to stay positive. So in this case, x has to be just the square root of 3. So let's go ahead and just mark that here. Okay, and so now we can get some great insight into the values of other trig functions from this little picture. And so that's what we're going to do now. So I'm going to walk you through this. We're going to start by finding the sine of 30 degrees. So remember, sine of 30 degrees is what? It's opposite over hypotenuse. So here's my 30. So here's the opposite, 1, and there's the hypotenuse, 2. So it's going to be 1 over 2. Okay, so let's keep going. I want to find also cosine of 30 degrees and tangent of 30 degrees. Okay, so cosine of 30 degrees is adjacent over hypotenuse, and tangent of 30 degrees is opposite over adjacent. Okay, so now if I want to find these, actually I think this would be a good challenge to you. You could pause the video here and see if you can figure this out and then hit play. So here's my 30 degrees. So the adjacent side is this square root of 3 and the hypotenuse is 2. So square root of 3 over 2. And then for the opposite over adjacent, so this will be 1 over the square root of 3. So square root of 3 over 2 and 1 over the square root of 3. Of course, you have to rationalize this. We can't have the square root in the denominator. So here is the rationalized form. And so if I know the value of these 3 trig functions, I can figure out the reciprocals, right? So then, just to finish this, so I take the reciprocal of 1/2, so this will be 2. The reciprocal of square root of 3 over 2 is 2 over the square root of 3, and then I have to just rationalize like I have here. And then I had 1 over the square root of 3, so if I take the reciprocal of this, it's just square root of 3. And so now we have all the trig values of 30 degrees. Cool. Okay. So now let's, of course, find the trig values for 60 degrees. We've got all the information here, right, with this triangle. So what I would highly recommend that you do, if you feel like you've got this, pause the video here, see if you can actually find the value of all 6 trig functions. Hit play when you're ready. Remember, math is not a spectator sport, so if you're just watching this and you're not trying to do it, you are not learning. So I highly recommend you pause the video. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So just filling in then the values of this picture. So for like sine, so I'm going to have 60 degrees is here. So I go opposite over hypotenuse, right? And then for cosine of 60 degrees, so I go adjacent. So that would be this side. This is the adjacent side over the hypotenuse. And then finally, for tangent of 60 degrees, it's opposite over adjacent. So square root of 3 over 1. So just to round those out, we've got square root of 3 over 2, 1/2, and square root of 3 over 1, which I can just call the square root of 3. And then, of course, we want the other functions, so I can just take the reciprocal of everything that we were just looking at, rationalize where appropriate. So I've got, this becomes 2 square root of 3 over 3. I just went ahead and rationalized this. This is 2, and then square root of 3 over 3. Again, this is rationalized. All right. So those are some pretty special angle measures. I also want to talk about the right isosceles triangle. And so what makes this what it is, so we're going to have two sides that are the same length. And then the hypotenuse can be, we'll talk about that in a second. And you also have two 45-degree angles. So this is what makes a right isosceles triangle. So of course, we have to wonder then, what is the length of the hypotenuse? And we're just assuming that these are a length of 1. So this didn't come from anywhere. I'm just giving you this. It just makes our life easier. So just go with me on this. Okay, so length of the hypotenuse. So we've got 1 squared plus 1 squared. That, of course, equals 2, right? So then I'm going to have that, this is my c squared. So if I take the square root of that, this side is going to be the square root of 2. Okay, so of course now I'm going to ask, what are the values of the trig functions? So are you having fun yet? These are pretty important. That's why we keep bringing these up. Highly recommend you pause the video one more time, find them. When you've got them, hit play. So I've got sine of 45 degrees, cosine of 45 degrees, and tangent of 45 degrees. So I've got just my little mnemonic device to help me with this. So sine of 45 degrees, so that's going to be 1 over the square root of 2. So I can just rationalize that to get square root of 2 over 2. It's the same thing for cosine, right? And then for tangent of 45 degrees, so it's 1 over 1. So yeah, opposite over adjacent, however you want to think about that. That's just 1. And then, of course, going for the other trig functions, so now I just take the reciprocals of all those, so I get square root of 2, square root of 2, and 1. Okay, so at this point, if you've been watching my whole series, we have discussed the values of 6 trig functions for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And these values you really need to know, like, as well as those multiplication tables that you used to do. These are super, super important. So, like, you remember back in the day when you were a kid and you had to do, like, the multiplication table? So these values that we've discussed, these right here, you need to know those as well as you know a multiplication table. That is how important it is. So quiz time. I want you to save what we're about to do. Save this someplace where you can easily find it, because you'll probably find yourself referencing it. And it's very easy to forget these. So when I say save this someplace you can easily find it, I mean, think about this in the long term. So if you're in another class and then you need to go back and reference this, you will thank me later if you put this someplace you can easily find it. And I actually really recommend that for what we're about to do, you make a note card or make note cards of this chart and then drill this 3 times a day until, like, you know it like the back of your hand. It's so important. You need to know it just like you know a multiplication table. So important. Okay, here's the quiz. So I've got from 0 degrees to 90 degrees. Fill this whole thing in using whatever methods that you would like, either what we've just discussed in the video, or you can use standard position. And actually take the time to figure this all out. It might take you a little bit, it might take you, 10 minutes, 20 minutes, something. This is a worthy exercise. So pause here, hit play when you're ready to see the solution. Okay, so I've gone ahead and filled all this in. I can't go through why these are what they are, because that would just be, that would explode this video into like an hour long. I've built this up in a lot of other videos, but I will leave links to finding like these two values, 0 degrees and 90 degrees. I'll drop a link to that in the description if you want to go back and review that. We've done that in my class anyways. We've done that from standard position so far. Although you could also use that 30, 60, 90 triangle to figure this out. Okay, so I have a free practice chart of that at divideandconquermath.com. So if you want to continue practicing that, I highly recommend that you do. And then if you found this video helpful, please consider leaving a like or a comment, sharing it with a friend, or subscribing. And otherwise, that's it for this one, guys. I'll catch you in the next one.